We are there yet. Hello everyone. I was just recording some B-roll. So sorry for the slight delay. I have
streaming science or technology. M.2
wait. I need to connect my headphone, otherwise TTS will be okay.
EY.
Need to reconnect my phones. Now. These annoying bees are flying around all the time here.
Hello.
We have so warm weather, I really enjoy it. So if there is some buzzing noises, that's just of the airborne insects that are annoying. So hello Sonic, hello Dutch, hello Kasper. I hope you grab your tea fast.
These are not annoying as they gives us honey.
Wait.
Close.
I don't know. These are the big ones. I don't know if these
Hi
are.
Everyone. B is for bitluni.
Sorry. I still trying to connect to my
Oh. Echo.
headphones. Sorry.
Stream started out at 25 speed.
My headphones are not connecting to the PC. Annoying. Stop being annoying, stupid headphone.
Bluetooth.
Yeah, classic Bluetooth, huh?
Hello. Also, hello all listening. Wajah mata berkedip.
My phone also didn't want to.
I hope I have the right ones connected.
I like hearing my pseudo self.
Your pseudo self, yeah. But that's over now. Okay, I got the TTS under control. So I didn't do nothing since Monday except for editing. So oh yeah, I missed a few people. So Johnny, Kasper. Oh, so many. Yombo, Nishai, Wagon Loads, Basil. Hello. High-pitched voice. Yeah, it's random. Basil, it's random. You need to check on screen help, and then you can set the pitch of your voice. If you set 1, then it's normal pitch. Otherwise, it's it's just to distinguish the people if I'm not looking at the screen. Hey TMK, how was your power? Did you survive the outage? So, we had some recap, my friends. Oh, the LED matrix is running. I tried to stream because some of the footage is crap. I want the results to look really excellent. And that's the only thing that's missing, like at the end, like nice results. We got some cool stuff there. I don't want to start Resolve right now, but quite often the lighting is bad. It's like the focus is bad. It doesn't look good. Especially not for my perfectionism. Alright, but I will just complete this today in the evening, and I think we won't do for very long today, so can't AI fix it? Yeah. I noticed AI messed up with my screen share because it should invert. I need to fix that in the code. I so the footage that we had on our LED matrix was of Doom. It wasn't very recognizable, so I found Doom 2 in black and white. So it's actually, you have more contrast. Yeah, so I'm trying to use. What? Microsoft said 30% of their code is already from AI. Yeah, probably some code review and refinement. Like new products, or like they're not overhauling they like old code. They're just rewriting everything. Well, that's actually crazy. I'm wondering if there is some of Microsoft's core code from Windows 11 or something. I mean Windows 3.11 in ChatGPT. You can ask it. Oh no, it's not ChatGPT. It's Copilot with them. Microsoft is Copilot. Everything's so dusty. Okay, short recap on what we did recently. Yeah, you're looking at some. Yeah, actually, I had some like suggested some code that looked very familiar at the beginning of that, especially when I was doing like microcontroller specific stuff with I need to turn off the LED matrix before this computer dies. I really need it for my other ventures, so let me turn off. Or we can send it to sleep. Sending it to sleep might also work. Yeah, it turns off. Nice. Okay, so no overheating there. I hope so, at least. But I think it's shutting down completely. Yeah, still recapping. Here is where we are. We made Didn't you say you had a sponsor commitment for the M.2 Matrix video? No. I have for the M.2 Matrix video, but I think Eisler is they are all flexible, and I asked my manager regarding, it wasn't about the matrix, it was about the cluster, and you know the state of the cluster wasn't far from finished, even though I sent some material to my cutter already. I don't know how far he got with that. There was no way I was able to complete it until today. And I asked my manager, and he said it's very they are cool with that. So I even extended it. Like I told them, or I told my manager to tell him it will be like postponed by 2 weeks, because we are almost there, but I want to be like less stressed about it. So this. Hey, Dojo Drummer! Nice. Alright. I hope that answers that question. Yeah, here we go. Where's face looming here? And I will probably put something on camera so we have a better resolution here. Oh, yeah, zoom lens. I'm filming with the prime because it's looking so good. The bokeh is so nice. Who watched Gerald Undone video with Legal Eagle? That was cool. What? You still do that with Firefly? Okay. Here we go. Tony? What? What did I miss? Is this another meme from Gerald Undone? No. There's GH5 camera. Yeah. He has a cool niche, Gerald Undone. I don't know, he has some good sponsor contracts because his reach is sometimes very good, sometimes it's alright. I mean, he does the sponsorships with, what was it, this website thingy. What was it? Elements? No, what was it? I don't know. And sometimes his videos don't get that much reach, and still he has a comfortable life. Hey, Olive Time. Anyways, back to our project. So this is old project, M.2 matrix, and we were very, very lucky. Yeah, okay, that was second revision to get the PCI Express running. What I got now is I designed this board. Whoop! Zoom in. Focus, focus. Oh wait, manual focus? No. It's just bad aim here. Alright, here we go. So I put it on the back of the M.2. We have like 1 millimeter in the specs, or 1.5 millimeters on the back, so it's might barely work. So I changed a little bit, and I thought I broke it, and I was just missing this little 0 ohm resistor. And yeah, on Friday I thought it wouldn't work at all. On Monday we realized, or our chat or people here on this channel in live noticed the missing 0 ohm resistors that I wanted to replace beforehand, and then just forgot to place there, which is very crucial to getting power to the PCI Express communication part of the interface chip. Anyways, it was recognized and it worked. The only thing that we had issues with last time was the reset circuit, which is over here. Yeah, famous 0. Yeah, the reset circuit somehow seems to be floating or something, because we had some issues programming the microcontroller over serial. So serial works, but something's off there. Or we have the PCI Express quality is so bad that it messes up. But I wouldn't think so. Like, there's some error correction and CRT and so on. Yeah, on this side, people who have joined just the first time, there are just more M.2 connectors, and one fell off because I did a poor reflow job here. We will reflow it by hand with a contraption that we just figured out, like with some wire wrapped around the soldering iron tip, because we need to get in the tight spaces in between those connectors. Where's the connector, by the way? Must be somewhere here. I hope I didn't lose it. I have some spares, but that one was pre-tinned already. So where did I leave it? What's the anticipated power? I hope it's below 1 amp at the end. I hope. Because I mean the serial chip already takes around 200 milliamps with that. So this takes 170. There's some losses probably here. This one probably takes another 100, so we are at 400, and then we have this here, which is razor blade. Yeah, but then I need to heat up the razor blade properly. I don't know, and this will do some bridging. I rather want to have one. So this is the cluster, 16 MCUs, and at the end we have 10 more didn't fit. So with this one that's missing, it will be 10 sockets for this cluster, which only uses the same socket, but it's not compatible with M.2. So this is M.2, this isn't. And yeah, so it will be 160 MCUs, and then if you calculate right, we have like around 5 milliamps. Then you can probably draw like 2 amps. So yeah, 5, 10, 20 milliamps per MCU would be possible. And then we have 160 MCUs. Let me get this on camera. So I have some teaser for the next project for my video. Alright, let's film that in. It's not the beautiful camera, but okay, that is filmed. Yeah, so the plan is fix the cold solder joints, solder on some wires to check, to scope what's happening with the reset circuit. Maybe check if there is a cold solder joint. I would like to replace also the diode. Here. Do I have a small diode somewhere? As a quantum computer. Oh, wait a second. I have small diodes on this mini boards, and I have plenty of those boards. Here. I have plenty of those boards, and there is a diode on top of that. I could use that. Yoo-hoo! Okay, we can take a small diode from here. Why didn't I notice that before? It could probably mine 0.0000001 bitcoins a day with that beauty. Yes. I mean, it's integer values. It doesn't need to fold proteins, and it's all right. Like, what is it? 48 megahertz times 160. It's slower probably than one Pentium core or something, but. Anyways, hey Alexander, who else joined? All right. What? LEDs become useless here. Yes. We can just turn them off. They are controlled by the. It's just for. And I used Ember. Ember. We can check that. So that's quite interesting. That's why we don't have pink LEDs in that case. I can share that with you. Which parts I used. Because if you take like red values or amber, there are like LEDs that are not drawing like 20 milliamps, they're drawing only 2 or something. You don't need high currents if you stay in the warm color range. Order history. Let's see if I can get the details here. Order details. Yeah. They don't show. I have a production file. They don't show which LEDs I took. Okay, some production file. I don't know what this production file is. Yeah, I can't tell you. I could go to JC parts. Assembly file. Assembly file? Wait. Where do you see this assembly file? There is a production file. Gerber file. Is it Gerber files? No. I don't want to dox myself because they show the address. So where do I show that? The main file below the main PCB. Oh, you're right. BOM file here. Yeah, let's open that with Microsoft Excel. Yeah, no. What the fuck? Wait, what? That's the wrong. No, that's not a proper positions detail. View detail. Ah, here we go. Bill of material. Ah, yes, yes. Here we go. Extended. Yeah, it's red. I don't know what the part number. We take that and go JLC parts. Okay, 0402 indication light, data sheet. Okay, can scroll. Oh, rating. It's rated for 20 million. Okay, I take back everything. Didn't I pick it like... What? Okay. This is bad. I can't light them all at once, otherwise this mini PC will melt. Ice 9 cooler from... yeah. I don't think the problem will be the heat, the problem will be that the mini PC isn't able to supply so much current. Like that, this will be too 3 amps, 3.2 amps just for the LEDs if they light up all at the same time in full brightness. The pin might be able even to supply that power. Oh yes, I have. Wait, I have a series resistor. I took. This is capacitor. Wait. Resistor. Is this a 2K resistor? That would be strange. What is this part? We have a part in that's 200 ohms. Shit. Oops. Ouch. Ouch. Oh. Can you calc it quickly? What we got with this LED here? Forward voltage. What is the forward voltage? Forward voltage maximum minimum. So it's around 2.2, 2.1. 6 milliamps. 2.1 is forward voltage from 3.3. Yeah, whatever. It looks cool. we will PWM it. Some dimming, some serious dimming. Anyways, yeah, that's that. $5.5, yes, alright. That's alright. Fail to receive socket, yeah, whatever. Okay, this stupid bee is confused. I will turn off the lights for a moment. Here. So it will find its way out. Okay. Now go away. Okay, it went away. It thought it's the sun with my studio lights. All right. So we will do. B is alive. Yes, it is. I think you're fine. MCU is max 7 milliampere plus 6 times 163 plus 300 for other stuff 2.38 amps. Yeah, and it will probably the since we are quite the cluster uses only I think 2 pins for a VCC. So this is also a current limiting thing where the voltage will drop even more and the LEDs will be dimmer even more. But the pins might be rated for 1 amp, but I believe they have some resistance. Where is the connector that I lost? I hope I'm not rolling over it with my chair. Currently, something's dragged along here. Oh wait, that's my lead here. Huh? Why did this light turn off all of a sudden? Huh? What happened? Did it die live on camera? I had problems with this light before. No, doesn't have any power. Huh? Hä? Nope. It's dead. Oh, it refuses to connect. For some reason, does it? No. Hä? Lost connection or something. We might need... I'm hacked. Alright. NTC, what's NTC? We will fix it. Oh yeah, to-do list. Oh, oh, okay. I might want to, if you like to ramble, I have some things that I might want to discuss first before we continue with the to-do list. There is it here. I did some research, some notes. Oh yeah, that is what I want for the ideas. Using the programmer, we can store the numbering of the individual MCUs in the array, which is easier with the programmer than it is with the other thing. As soon as we got like all the arrays, they're in parallel. So might be a good thing. I don't know if we can write into the user byte. Maybe Basil knows that. Let me check. Maybe that you can. There should be. Okay, this is the flash. Data. Is this in some way or form data free to use? Basil, do you know that? Oh yes, that's what I thought. High five, high 10. Yeah, that's what I thought. So we can get just when we flash the initial firmware and it boots up, we can make it like the main CPU of the programmer. So let's talk through the nodes. The programmer board has the main CPU, and this or MCU. This MCU could in series do the following, because it's connected like to the same pin where the LED is connected. We have an individual line, and we can make it pull down and up. Oh wait, this is the MCU. The CPU is my main CPU or main or host. Host. Let's do host. Okay, so the host has either floating or up, and so it never pulls down. So we don't get like a short or something. And this MCU can detect whenever the host is pulling it up. Hey Quindor. When the host is pulling up the LED, the MCU knows, oh, next data is just meant for me. And then we can put on the bus, you are, since the host knows which pin it pulled up, it can store or put on the bus, you are the MCU number 1 or whatever, top left or whatever. So we can actually store the position. Yeah, it's like a chip select, but it's a little bit of inconvenient in this case, because I decided for some reason I did it different on the other. Yeah, on this one we have like the second GPIO can be used on the pin header here. So I took like the second GPIO, I routed to the pin headers, and I didn't want the LED to be connected to this because we can use it also with analog or whatever. So this is what I decided to do here. And on the M.2 there is no peripherals or whatever, no header. So I used the second GPIO, which is the second pin is used like for poking it, but it pokes like all the cards at once that are placed in the M.2 board. Yeah, so we can give it like an address, and then whatever we do, like put on the bus card this and this. Oh yeah, we can clock individual cards and say on the card as the address, oh yeah, MCU number 1 is meant, and then that's easier to do. And for simplicity, I might not do an open bus where all the MCUs can talk. For now, we can do this later, where we do like some neurons that can fire in all directions. We can do that maybe later, but in the beginning, the host will control everything and will just send tasks like MD5. You have like I think for Bitcoin mining you have like a nonce or whatever. How's it called? Like a portion, a header with some data or last hash, and you generate the hash from that, and then you compare the last bits if they're all 0. And it's getting harder to find like a hash. Like you need increment 1 of the number of the header that you hash to find like all the zeros at the end. If you found them, you found a block of Bitcoin or whatever you're mining there. And yeah, it's getting harder and harder because every time it gets like 1 bit more to find as a 0, like doubles in difficulty. Really? No. Is it? And there might be also different hashes might result. It's not like linear, but different hashes could also result in Hasmon to program the clusters. Yeah, we can try that. That would be certainly one thing to try. Oh yeah, so much to talk about. Rambling session, but we like only for a few more minutes. Okay. So, anyways, where was I? Okay. We can calculate just hashes, and then every, I don't know, certain number of hashes that we calculate and increase the nonce on individual MCU, we can just ping the host, or the host can ping the MCU and take, oh, how many hashes did you calculate, and then we can generate nouns, nicht nonce, not nonce, it's nouns. Okay, nouns, it's a nouns. All right, sorry about that. So we can then use something like this. Would be cool. This would certainly look cool. Make an email that simulates a task manager with 160 CPU cores. You can try that. So where you were? Ah, yeah. Okay. Nouns. Okay. I thought my pronunciation was wrong. Let's check that. What it generated. New file. Course. Okay. Let's test that. Okay, so something like that, but I want it to look like more like. So this is certainly cool. You're not seeing all of those, so there are more. They're underneath the chat window here. Yeah. We can make it. Okay, we can ask it. That's so cool. Okay, make it look like Windows Task Manager and let each CPU have a small utilization graph. This is so. You know what's really strange? Who mentioned that Microsoft's code, like 1/3 of Microsoft's code, is already generated? I have I feel bad for asking something really demanding. Like I would talk to another person that has like a lot of work just because I have one simple wish and I want to see how it looks like. But if we look like our tool, it's done and then it suggests something, it wants to do more. So actually we shouldn't feel bad. Oh, where's my... Oh no, where's my... Okay. We shouldn't ask it... We shouldn't feel bad to ask it really demanding tasks that would take like ages to code by hand. It's so strange, like to rethink. Oh, it got like doubled the line count. Okay, let's see how it looks like. I don't know if I... Oh, what? Why didn't it... Where's the graph, eh? What did I do wrong? I saved it. Huh? That didn't work. What? Welcome to the... Hey, God! Yeah, demanding task. I just drop a ton of recordings where I forgot to turn off the camera, and you have like to listen through all that crap. I'm so sorry, but you get paid. You get paid. You get paid by the minute. This is not... Something didn't work. Something that looks like the one before. Huh? What happened? Did I copy the wrong thing? I thought I... Wait. Yeah. Oh god. I'm still editing Carl. Oh, here we go. I copied the wrong. Oh, yes. Yes. All right. This is cool. Okay. Make the graphs less volatile here, because they're jumping all over the place all the time. That doesn't look genuine. We can just use that and grab it for the video and fake it till you make it. Nah, not faking. It will be easy. I just tell it to get the data from the MCU. Wait, copy? What do I do? What do I do? Update it. Oh yeah, it worked! I dream of the day my real task manager looks like this. But I like it already. Look at that. That is nice. That looks like a random walk, but still. Nice. Okay, so this is what I imagined like for the video of that thing that Carl is currently editing. The ARM CPU with 128 cores. Yeah, but it's not 160 cores. It's only one. ARM CPU. Crazy. Yeah, I mean, you can just take a graphics card. We want real-time ray tracing on that. Ampere A1. Oh yeah, I heard of that. I can remember. Yeah, it's still... Bro, beat it. Yeah. Oh, whoever wants to code for the a small ray tracer, a distributed ray tracer, you're welcome. Welcome to do. Epic Zen 5 is up to 9. Oh no. Uh-oh. 192. Anyways, this is our wait, to-do list. Yeah, for servers. Yeah. All right. Okay, so that was one of the MD5 in counting host poll count, and then whatever. Oh yeah, this is host clock. Long is reset because I have like I don't have extra signals for indicating new comment or whatever on the bus. There is nothing basically but the clock. And if I can just trigger it for like 2 clock cycles or a full clock cycle, and then we can do DDR, like double data rate. If we do like 2 clock cycles or whatever, it means like a reset or a new comment starts, and then we have like address comment, address data, whatever. I didn't think that through yet. We have to wing it next week or something. Anyways, at the same time, since I'm not very satisfied with the serial CPUs, I was... this is so cool. We can talk about some tech, because I was talking to Anna yesterday, and I don't want to reveal too much. Yeah, I was looking at another MCU, and this is basically it. And I just started maybe to design. I just removed the old crap, and this is what's the name? Renaissance. What I liked about there, that's an PCI Express to USB 3 or 2 controller. It's quite pricey, $5 or $4 in, if you, what's the name of the company? Renaissance. Whatever. They are not very open with circuit designs or whatever. You can get some. Okay, this is like for the bigger one, an example, but this is like, okay, they have some. I needed like, this is behind like login and whatever, so I wouldn't be even able to put this like with my project files on the web. I think, at least I read some terms. It's quite cool. It just needs the crystal. That's more, and it uses actually SPI flash. It's not Renaissance. Okay. It also uses a diode. Why? Renaissance, yeah. What I'm asking myself, they have in this circuit, they have reset. There is a test point, and then they have like clock required is not connected. This is like a PCI Express thing. I don't know why they didn't connect it. Maybe I should do like a solder jumper here. It's quite strange. I don't know what SMIB is. Oh, that's SM bus. Oh, yeah, right. Okay. That is SM bus. Yeah, we don't have, I think I'm not using SM bus here. Oh shoot. Yeah, no. Yeah, it's not connected either. So, and there are a million caps on top of that, and they have like oh really? Grok is that good? Isn't Grok like Elon Musk's stuff? I want to boycott Musk stuff. They have some cool noob design recommendations. So I already failed. So if you check my circuit, okay, I'm doing exactly what's wrong here. So I do that. Then okay, I have no sharp corners. Impedance matching, yeah, no, blah blah blah. Okay, I do that void. I do that void. The clock line. Okay, yeah, I don't have that. Might have that. Yeah, here. Not connected as well. I have that. I don't have that actually. Okay, there is one thing that I don't. That's bad that I don't have in my circuit. Right, but it's quite cool. I mean, you learn a little bit of how to do stuff. High speed. But this is really for like USB 3, and the MCU that I'm using for now, I mean, I want this circuit or to be a base for everyone. since I do it open source, and maybe for my later projects I want maybe USB 3 to be supported, but for now I can do only like high speed at most. Yeah, I don't have that. All right. Anyways, and I want to. I just need to ask you people. Does any one of you has Sony NT1 or NT2? NT2 would be even better. I need that device. It's digital tape. I won't spoil too much. But it's digital tape and it's the smallest one out there by Sony. You have that? Yeah. There is a video about this is so cool. Wait, how's it called? Anti on back up. That's 1.2 gigabytes. Mini data. It's actually something like that. Where do I find it? I think I can't find it, peeps, right away. Someone dropped a. Yeah, it's the cassettes are really small. They're like 2.5 centimeters wide. So if you have like the Sony NT cassette size, there is like a size comparison. I saw a size comparison. I would love to. They are so. This is basically an obtainium. If you want to get you get like $250 for a record player. This one here. They are so rare. Here's an audio cassette in comparison, like to these cassettes. Yeah, 2.5 centimeters wide. And compared to like, where is it? There are the small, the other small, oh, this is crazy. They are quite sensitive as well. Yeah, mini cassettes are like twice as big. Oh, what is this? I want this. This looks also cool. Look at that. What is this? Imagine that, and we use this with the C64. Anyways, not to spoil too much, imagine putting something like that on an M.2. Where is the data? I ate it by accident. Yeah, it might happen. Is this a Sony device? Yeah, this is unobtainium. Yeah, that's true. That's true. The Sony was like really good at this. Anyways, let's do the to-do list and continue with our stuff. So today, fixing Fixing cluster base. Task 1. Check reset circuit. Then second, replace diode. Oh, a cassette. Oh, that's cool. Wait. Walkman smaller than cassette. Do you know the name of that device? Here, smallest cassette player. Here we go. This dude, Elliot Call, has more subscribers than me. That's true. Okay, that was a Walkman. And now what is this? It looks so cool. Bitluni reacts. Huh? What is this contraption? Oh, look at. Oh, this is the same. Wait. I wanted something like with mini cassette or like. Oh, like this? This one here. Toshiba. I'm full-time maker. Yeah, NT tapes are coming. What? Is this like a mock-up? This is not real. Does this exist? Oh no. What is it? Can you see? Oops, like couldn't find the page, but it's still cached. What's the name of the brand? Elbow. That's maybe fake. The Toshiba. Oh, someone holds it in. I found the brand. Kopfhörer.de. This is crazy. That's a concept. Yeah, that's just a concept. Probably never worked. But I like the concept though. That's yet another. Look at that micro cassette. Micro cassette is like is also alright. I mean, it's twice as big as this one. Okay, we can take that, but that's probably also unobtainium. That's like collectors. Circa 92. That's nice. That's probably not longer than 8 centimeters. Yeah. Cool. Okay. Now you're in the rabbit hole. Replace diode. Then touch one. Just check scope. Then scope time. Then we need to solder the connector. Oh, didn't arrive yet. Wait, did it? Didn't it? I ordered it. Where did I order? On eBay. Didn't I buy on eBay? Let me check if it was shipped already. Yeah, it didn't arrive. I could check the mailbox if it's arrived already. Let me check. My girlfriend, if she checked the post box today. I completely forgot about the flash. Okay, solder the connector. Fix, solder, gold, solder joints, and that's it. That's the goal for today, I would suppose. All right. Where's the connector though? I have so much trash on my table that I don't know. Toni, hast du nach der Post heute geguckt? Also es war was für dich oder was? Okay. It seems there was already, but nothing for us. So I will wait for the flash. No flash today. We lost the connector. It must be here. I wouldn't move it away from here if I put it here. Yeah, I can see it here. Damn! Just lost it. Treasure hunt? Yeah. It's odd, it's not that small that I would lose something like that. Oh, my socks, yeah, you check the floor if it's there. I certainly found some wires that we can solder on to for the scope time. Test point wires. It's not here either. Alright, anyways, I can just take a new connector with. Oh, there it is! It was always here. At the soldering station. I guess we will use the microscope all the time. So we switch that. And I might want to record some video while doing so. Sounded like there is an insect here. Or a short. Yeah, I need to turn off the mini computer because I need also the power supply. Okay, I think this will be bright enough. Are you still there? Yeah. All right. So here we are. Trying to fix our mistakes. Doesn't look like cold solder joints anywhere here. Where's this insect? Eh? Stupid insect. It's annoying. Maybe there is a code name. There doesn't look like there is a cold solder joint. With those lines anywhere. But we have like 100k resistors, and this looks a little bit too dirty for my taste. Here, maybe we have some leakage current. Well, it's not like 1 million ohms. Can you see that? I don't know if you can see that. There is like here. Yeah, I can see like zoomed in like that. Danke. Okay, there is no post for me today. Let's salvage this little diode and put it on. Well, I think I won't be able to use that hot air because it's set to a different Did bitluni die? No, I can't hear you. Or is everyone gone? Oh, sorry. Okay, you are still there. Thank you, thank you. Yeah, we need a new potential quote. New potential quote generator. Now we can use AI for that. Is there like a Node-RED interface for OpenAI? Okay, there is our diode. Oh, yeah, you're right. It would be way easier. Tweezer tips. These tweezers are good. Yeah, it was. No, it's because it has like really outstanding. The rim I was able to touch the rim with of both ends, and it's low temp solder paste, so I can't see the line anymore. Need to refocus that. The right way around. I hope we are. Yeah, this is the right size diode. Alright. But is it the right orientation? We'll find out. A second. Oh no, yeah, I can. Yeah, there is the line. We pick off the paper. Okay, LED is sorted. I just want to get rid of the gunk here, maybe. Ah, but this is only. Where's this buzzing noise coming from? Yes? Alright. That's cool. Yeah. So I will attach something. Shit. It's strange. It's eroded, or what? What is the issue here? What is? What happened here? Is the cold plating gone, or is this like hair? What happened to the pad? Something strange happened here. Oh no. Oh, now it's fixed. Okay. So I will put ground first. Then reset. And now we need to find boot 0 and 1. Where is boot 0 and boot 1? One of those should be boot 0 or 1. Let's load this. What? Chat wins? Sony EX1. Let me check that. That was yours? Sweet. I have like a super chunky one from 90. It wasn't even able to rewind, I think. There were like Walkmans that couldn't rewind. They're only able to spin in one direction. Oh, bad change? Yeah. I can hear something buzzing. I'm wondering if it's an insect or some. Where's the buzzing noise coming from? So strange. Hey Marcus. Okay. Cluster base. Hä? Drives me nuts. Okay. You can't hear it, but it's like a reoccurring buzzing noise, which drives me nuts. this is VCC here. That's a reset. RTS. Alright, I need to find this in the schematic. Okay, boot 0 is on the bottom. No, it's between these two here. Buzzing's fun when the boss talks to you. And this one is over here. This could be also the cause. Yes. Okay, so this is on this side. And then we have one down there, here. This is PB2, which is boot 1. Okay. Let me sort on the wires. The hood for my HVAC. Oh, by the way, I got my new paste. I could use that. So this is boot 0 here. Oh, this one is still recording crap. Ah, shit. Throw this away. Ah. Turned off. I don't want to place it like that, that will cause shorts. I will bend it around. Okay. And the other one is over here. All right. Let's see if we can test that. Bitluni. Yeah, it's not a botch yet, it's just testing. Testing. Testing, go. Testing go. This is the ground. I just need to be sure that I don't short anything. Huh? Oh yeah. Okay. Now scope time. I can see it. I can see it, the buzzer. The buzzing buzzer. Damn. It's up there. At least it's not like a short circuit or something. It's yet another of those bees. Oh well, it will stay there for this night. It's not a mosquito, it's one of those stupid, super thick bees. I don't know if it's even a bee. It's like those wild bees or something. No, this is the wrong. I need a cable. I need a power cord. Give me the power cord. No, it's not even a bumblebee. It's like a super chunky, big. Looks like a bee, or it's not the hornet. Hornets are like have a pointy back and are black. Oh no, hornets are not black, but they're like, this one is hairy. That's why I'm confused, you know. It's not like a bumblebee. Bumblebees wouldn't fly like and look for a place to nest. Maybe I can show it. Maybe we will see it. When it tries to fly, I can. No, it's not a new species. Okay, yeah, I take the hardened file here and try to. Where is it? It's on my bag. Huh? Where did it hide? Oh, it's behind my LED wall. What the fuck? It's like it's talking. Come out. Don't build a nest there. Come. Yeah. Driving me nuts behind there. Come out. Show your. Ah! My lights fall off because they're not properly mounted here. Stupid bee. Alright, it has to stay there. Destruction gone. Okay. How is this? Member of the lab? Yeah, it will be a dry member in a few days. No, I'm not sleeping here. I'm not sleeping in this room, so I'm not worried at all. Stupid thing, it's just waiting for me to be recording my video and then buzzing in the middle of that. Let's get some probes. Let's get some probes, my friends. Ah. Okay, 3 props should be enough for everyone. Famous last words. 1 ground should be also good enough. Oh wait, how do I not cause a short here? Bzzzt. Yeah. Okay, this is ground. This looks like I will short something and then magic smoke will escape. Oh! A follow! Simi, hey! You are the 888 follower. Nice, goal reached. This is that. And now, never. We just don't touch anything anymore. Okay. Eh? Okay, this is 3, this is boot 0, this is reset. Wait. That's high. Okay, not reset is high. The others are just 0. That's alright, this is what we want. Now I will lock on and we will see what happens. Maybe it's fixed because we changed the diode. ENC, okay, connect. Connect. Should I share it somehow, like? Oops. Which one is it? Sometimes it's really hard. Okay. That. Oh. Yeah, well, micro cassettes. Okay. You check on Discord. Lab. Oh, nice. That's that's audio, or is it like backup? And the micro cassettes, yeah. Or mini? No, it's micro cassettes, I think. Yeah. Maybe I will just share the picture. You can open this in a browser. Open link. Here we go. So here we go. Yeah. And the smaller Sony thing is even smaller than that. 2.5 centimeters. This is probably like 2.5 centimeters. It's crazy. But these are still small. I like. We should try to store how is digital data stored on audio cassettes on the C64? Does it use multiple frequencies and then some, or is it just like modems stuff? No, modem does. Does modem use different carrier frequencies and then just some signaling, whatever? Okay. We wanted to do this, so let me start recording. We can, yeah, doesn't matter. Okay, change. Now okay, so I cleared RTS. Now boot is high. I clear DTR, both are low. Wait. No, reset is high. We should check with our simulation. Where's my simulation here? Damn it. Here's the simulation. Okay. Let's check with the simulation. I also recorded this today. Okay. Ah! Shoot. Okay. Pins. Where did that go again? Okay. So we have clear, and then a reset is okay. Boot 1 should never change. Oh wait. Scope view needs to be smaller. Okay. So boot 1 will never change because it's just pulled down. That's all right. So we just take a look at boot 0 and reset. So the first two. Reset is high. That's the first signal, the upper one. That's alright, not reset. Boot is 7 microvolts. Alright, so sorry, the sim scope is still like that. Alright. So let's close DTR and let's close, let's set DTR here. Now reset is low. No, it's not. Oh, the signals are inverted. Wait. Reset. What's going on? DTR. Oh yeah. DTR. No, wait. DTR is set. This is wrong. I need to clear and set. Why don't they use toggle? There's no toggle, but I don't see anything happening there. Wait. clear, set, clear. All right, okay, look at that. Reset gets never below whatever. That's the issue. This is the lowest state. Let me check. Lowest voltage is right now. Come on. Peak to peak. Okay. 2.1 volts. Yeah, that's too high. Okay, we need to check how to pull it down. Yeah, I know, that's too high, but why is it too high? So reset is high. Oh, I might know why. No, I think I used 100k here, not 10k, because I don't have. Wait, I don't have those. Ooh, I don't have those here. What is my circuit? I used the 100k ohms resistors. But we can botch that. We can change stuff up and be good. Oh no, this is, yeah, that's cluster base. DTR RTS. They're pulled down. Yeah, RTS, wait. It's pulled down. That's that. I'm pulling it down only with like 200k in the end. Wondering if that might be the issue. Yeah, it will be. That needs to be... That needs... No, it's 10k. It's correct. Damn. I don't have... Yeah, these are... The array is 10k. Alright, okay. So where's the problem here? Wait, what is this? Huh. Where is this one? Oh, here. Okay, no, never mind. How do I fix that? How do I fix that? Set. Clear. Oh, you're right. That's the difference. No, wait, DTR is... There is no 100k here. Okay, that's 20k in sum. So that's difference. Oh, RTS. Oh. Wait, where is this 100k? I had like 200k's. Did I mess up again? There is 100k, there is another. Oh no! I oversimplified. Damn! Ay, 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 ay. Yeah, that's the issue. How do I select this stupid connection here? I don't want to... Okay, here we go. Okay, DTR, and this needs to go here. Yeah. This is the correct circuit. Okay, so we need to fix... Okay, I messed up for recording. I had this directly connected to ground, not to that. So I need a botch here. Let's botch that and then it will work. Alright, so... And I hope it works after that. It's like working with stupid. Hey Artem. Good, good. We fixing stuff. It's only affecting boots. Uh-oh. You mean... Oh. So, let's check what could be the issue. Let's identify it. It's pulling up all the time. It's too high. This is 100k. This is 10k. Did I get the wrong resistor here? Yeah, I know, but it was inverted in with the signals. Okay. Huh? Oh yeah. Oh, right, okay, okay. High. No, it's... Why is it so slow? Sure. Okay, sim speed. There you go. Let's find the culprit. Oh, wait. Reset high. Reset low. Why would this be high? In what case? Only in the case if this resistor is too high. That's alright. The discharge speed doesn't matter. But if this oh wait, low doesn't affect it. Doesn't flow in this direction. Wait a second. Why is it low? Pull down on the reset. Diode is backwards. No, I mean the current would flow in this direction. If it's high, then it's pulled up. But why is it low? Why is it low now in this case? We have like currents coming from this direction. Why is it low in the simulation? The simulation is wrong. Don't tell me the simulation is wrong. If we remove the diode, oh, you're right. 10K, the transistor, this pulls it down. Okay, that makes sense. But then this is somehow messed up. That doesn't pull down enough. Oh, you know what? This might be the issue. The current, oh no, I mean this is also a 10K. So if they're both 10K, if this is not 10K, if it's higher, that might cause an issue. But what if I change 100K to a low? Oh, you mean? Oh! You're right. we forgot the model. Here's the issue. The microcontroller has an internal pull-up. And it's lower than, it's like 40k or something. That's why we never get, we need like something, we need to model in the pull-up, the internal pull-up. That was missing. Oh no. In that case, let's say, what is it, 42k? Can someone find out what the pull-up is for the CH32V208 for N reset? Because it's like, I think it might be like in this range, somewhere. Now it's high. Right. Yeah, this will be always 2 volts, 2.3. Oh wow, we forgot that. So okay, let's change this value to something like 40k or no, we need like 33k or something. I don't know what's, oops. Let's leave it there. And now it's high still. No, it's low. Okay, no, it's, what's the value? 1.4 is still too high. So we need here 20k or something. 1 volt. That's alright. 27. Let's check that. 27 is 1.3. It's close. Yeah, it's a facepalm moment, certainly. Yeah, this is what you get. It's like 20k. Now we need to check the other states. Okay, boot is 2.7 because this everything is messed up with the values now. Both high. That's 2.1. Oh no, boot is 0. Yeah, internal pull-up for the N reset. 2.7, 3. That's alright. And then we have boot is 0, 3.3. That might be it. You just need to switch this resistor. I will share the new file with you, Basil. You counter check before we switch the resistor, but that will be an easy fix. I might be able. Oh wait, but I also need to check if it's still working with my messed up design. So I keep it like that. Keep it like that, and then yeah, we might need to redesign this. Share. Here you go. Okay. Let me remove that. That's so cool. Okay. We found this issue and now we need to fix it. Oh damn. Oh no, I I need to reconnect everything. Okay. At this point, I would just give up and use several UMH thingies. Basil, let's just give up and use just several UMHs. Or logic gates. Something very common just. Okay, let's find that 100k and switch it to 20k if we have even 20k anywhere. I think this is the one. Yeah, that should be the one. RTS. No, wait. RTS. Huh? Not DTR. Oh, that's not DTR. Huh? Wait. Huh? I'm confused. Boot 0. Okay, that's boot 0, but where's the... Oh, they're connected here. Alright, that's correct. So this is the one. Okay. 20k it is now. And this is our 100k to 20k. Let me find a 20k resistor now. I think you should fix the pull down on the boot 0. Yes, we should. But I think I will replace it completely. Now we have so many components, like even if it's only passives. The UMH, if we look at the... Let me switch the camera. I praised it so much, like so high, that it's so nice and we are so smart, or I am so smart for not using like, or using components that I have here and stuff. But the UMH is this size. And now we have the diode, which is the same size or bigger. We have like 4 resistors, 5 resistors, whatever resistors. There's so many stuff already. Maybe just putting the right like small circuit that does the best. Yeah, it's a small thingy. $100k in the emitter, how is that supposed to do anything? Yeah, Lasse, it's not like we need current there, it's just a reset. It's just the signal level. Alright, wait. We can use the UMH as a diode. Just inverting twice. But you need, for inverting, you need also a resistor. Okay, I will grab some resistors and be back in a second. Alright. I even have 20k resistors, my friends. So no worries here. Yeah, oopsie everywhere. Sorry. Okay, this is the one. I just needed to check again. Okay, replacing this 100k by a 20k. Bloop. We don't even need a botch wire, that's cool, huh? Here we go. Alright. Now I need to reconnect everything again. I won't botch the 100k pull down thingy in this one. We will work with that as long as it's working, even though the signals might be on the edge. Okay, we don't need boot whatever. We just need boot 1. We just need ground, which is here. And oh, this is hard. Oops, what happened? What happened? Zauberherd! Thank you for the follow. Okay, nothing shorting. I'll plug it in. An AND gate? No, 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 no. It's an XOR. More or less. It's an X. The logic is like an XOR plus something else. All right. Let's turn it on and then see what happens, huh? Oh! It fell off. Okay, at least it's signal level and they're not shorting anything. We can also turn off this one here. Oh, wait a second. Oh no, that's all right. I think that these are the two that we want. 2.3 volts right now, so it's high. Shouldn't be also like, I took the value so high because it shouldn't like drain too much current. Oh. Ah, okay. We're still there. Okay. The baud rate doesn't even matter. Okay. I should record this nicely here. Not like that. All right. We want to see. Uh-oh. Doesn't work. Brilliant ideas. No, it doesn't work. No. Now it's pulled down. We need to fix the 100K. Here. Low. 1 point. Okay. This is low. The other is low. This is high. High. Yeah, this should be. This is the issue. Now it should be. Boot should be higher. Ah, shit. Okay, not working. We need to fix that. Okay, I think this will be our only task today. Let me remodel that what we got now. Okay, reset is low. 1 point. Okay. Doesn't matter. At least in this simulation it doesn't matter. It doesn't pull high enough here. Why though? Oh, we made this one here 20k. Logic barrier. I don't know if how you can set this. Manual. Oh, on the real one. Wait. Might be that this is still okay. What is the... Wait a second. Yeah, you're right. Let me add... Oh, I had the wrong scale. Ah, okay. You're right. It works. Ah. Okay. Let me change that again. You will see for ourselves now that it actually works. Like in the sim. Okay, we have high, then we have low, we have high, low, and high, low. Yes, it works. Oh, thank you. Thank you for the suggestion. Damn. Okay, we are done. That worked. That worked. Okay. I can remove the wires. We should try programming it. We should try programming it. Wait. What was the thing? Web serial ISP. Okay, here we go. Yeah, this is one milli dollar question. Huh? The file is still okay. Here we go. It's still selected, but it's not really selected. This is, I don't know if you saw that. It shows as it would be selected, but you really have to reselect it. Probably even like that. Okay, that's... Oh, operation failed because real time is still open. Here we go. Let's try again. Okay. Now let's... Huh? Okay. Can I write? Okay, flash right. The default's strange. Yeah, right. That works. That works. Perfect. Perfect. Oh wait, did we see the signal changes on scope? Oh! We have the signal changes on scope! Oh, nice! That's awesome! That's cool. I've recorded it. We are done! We are done! Okay, connector. Let's solder the connector. And then I'm done for today. This is awesome. We got some serious work done. Peeps, thank you. Thank you for helping and fixing. I should save the changes. Yeah, this one worked. So this one here, let's change it just to 20k and yet another component that I need to put in the pick and place at JC. Here we go. This is the current state. Woo! Just replacing a resistor value is the easiest botch ever. Okay, let's do some scoping and fixing stuff there. Ah, okay. Not scoping, what do I say? Microscoping. I need to shut down this device again. I don't know. I don't think so. It's probably like an extension or something. Oh wait, here's something hiding. Oh, bastards! It's an extension probably. $12,000 for a scope and then you don't get HDMI. How old school is that? Yeah, we can use like the oh, we can do it over USB or yeah. Most probably like what's called like net what was the name? Net blah. The noise all the time from I hope you don't see cock. No. Like this standard screen sharing. No. Yeah, I I got all the features that I paid for, certainly. Here we go. Let's do it. Okay. Now we can remove the wires again. Look. Ooh, that looks dry now. also want to tin those here because they look nasty. Strange. What is that? What happened to this pad here? Some brown gold. Okay. Oh, how about this pad here? Okay. Now, the worst part, my friends, fixing these here. How do I even start? I can't focus. Wait. Nah, I won't put it in a reflow oven because the parts on the bottom will fall off. I really don't want to mess around with that anymore. Let's do let's do it this way. Wait, I have the new flux. Where is it? It arrived. Lost it already. Thank you for nothing. What? Where is it? Now bottom is with a lower temp. It's like low temp and a lower low temp. Let me get some really low temp. No. Yeah. No, this is higher temp. Is this higher temp? Yeah. This is 180 degrees. Unfortunately. I'll put it here on my table so I have access to some extra tape. And I hope that I don't. It looks like I'm messing up already. I did pre-tin them. Apparently wasn't enough for the last one, or I didn't heat it up well enough. So it fell off after the ultrasonic bath. Oh, we need to zoom in. Enhance, people, enhance. Yeah. Let me set up the focus properly. Okay. 0.5 millimeter pin pitch, my friends. This is really small. Yep. That solder board was too chunky. Look at that. This is the syringe. I can't even tell if this is. Here we go. Looks much better now. Oh, interesting. It's not heating enough. So there are some thicker ground pins here and there. You just need to be patient. Look at that. Looks better now. Just waiting. Okay, that is better. That's also better. This one moves, so okay. It was easier. You can bend this in position even here. Oh, it's not enough solder. Oh. Now it's enough. This one is also cold. You can see how it's moving. I'm wondering how we will do it with the wire in between pads, between connectors. Thankfully, I checked there are not many cold ones in between, the ones that we already have. Just soldering on. What is this gunk? Just grab some gunk here. Alright, we are almost there. This one. So this connector is for sure well soldered. Okay. Now What do we do? Do we put some even more extra solder on top of the pads? Yeah. Especially those that will be hidden. The bismuth might be already a little bit tarnished. What is this gunk? What is gunk? This will not help. That's some old flux or something. Yeah, bumblebee. Let me clean that up. And apply new. Nope. It's still there. Do you see that? Gunky. Okay, let me just remove it from the pads. And put some on here. I didn't smear anything off the paste on the bottom. What the? I would need something to clean that. That's cold. Okay, these pads are easier to solder afterwards, so I don't need that much attention here. Now let's oh, we might want to pre-tin this. Now that's also old and gunky. Is the pin bent? I think this pin is bent. Let me try to fix that. I don't have. So if you look at the tweezers, these are the tweezers. The tip of the tweezers is thick enough to bounce it back. Okay. Oh no. I did a too good job here. Okay. I'm experienced already, huh? Yeah, I can't get that off easily. Ah. Oh. Oh. Here we go. Okay, other side. Just move on and come back later. Ah, shit. Okay, okay. It's pre-tint. Now mating time, peeps. Okay. Oh, that's a good position. I mean, we can do this side. To knock bridges. Oh yeah, you're right. Oh, you're experts. It's standing off a lot. I can see sharp here. I need to readjust. I need to press it down so the pads are closer. This is the easy side. On. Ouch. It's size. It's hot. Oh, you can certainly notice that I'm tired. if I mix the languages already. Ouch. Oh no! Ah, I messed up this pad. Connector pad. Don't tell anyone. Someone followed? Thank you. Ah, slice back. And now we have 2 messed up pads already. I knew this might happen. Uh-oh. Solder bridge alert. I wanted too much. Oh, that's way better view now. I could cut this off. That looks already separated. Ah, that feels dry. It's tipping around this whole thing. Yeah, I need to get rid of all the solder there. Oh, yeah. You know the size of that. I need like Captain tape that's like 1/2 millimeter, not even 1/2 millimeter wide in this case. I could try to get underneath there, but the pin pitch is 0.5 millimeters. It's probably just as much work. Oh, I'm using low temp solder paste. Oh, you mean the edge connector? You're right. Because I'm lazy. That's the only excuse that I can give you. Forgot and lazy. Oh, come on. This one pin here. It's the last pin that I want to fix. This is like Lewis Rossman working on this scale. Looks like I'm still lacking. Ah, come on. Okay, now concentrate. This pad doesn't want. I think it's good enough. No. It's moving. Come on, stupid pad. What's going on? I lost it. Where is it? Yeah. All right, that worked. Oh, I found a good position. How to get some extra solder there. Look at that, nice. I don't know why this position is so good, but it worked well. Alright, so this side is alright. Now we need to solder these ones here. I will do the trick now with the soldering iron. Let me get the silver wire. I need to let it cool down first. Glue them at all. What? Okay, so I take this, wrap this around. Do we have insects already? Damn it. And this will be my new... Oh! Okay, it's getting hot already. So, this is my new soldering iron. I should film this. Okay. Patent pending, yeah. I can even put like solder to have a good bridge, but okay. Let's see. How well that one works. I might want to make it flat. Okay, I have now a flat tip. Like that. And I want a better lighting. Like that. Oh shit, this will be bad. Air gun. I don't have anything that would like fit in there. Yeah, I could. And the thinnest one. Yeah, this is. You saw the wire, no? This is like. Let me see if I can get even the solder mold in there. On the tip. Oh, it actually melts. Okay. I will get more solder around my soldering iron here. This doesn't melt because it's not hot enough. Okay, here. Okay, so the tip is now thermally connected better than before, I hope. Oh fuck. I see that going wrong. Can I hold it down even? Oh no, it's too cold. I need to get it hotter. Thankfully the soldering iron can do hotter. I've set it to 400, let's see what happens. Shoot. The shoe eating. Yeah. I might have too much solder on there. Oh no, the tips bends easily. It's so hard. How do I... Oh, that works. Wow. It actually works. I just need to get rid of this bridge here. And since I just grab I need more light in there. Surge enhance. Yeah, I should have became a neurosurgeon. Enough. Oh, it is enough, so okay, that's interesting. That could actually work. Grab off some solder there. If I forgot a pad, I also need to be careful because soldering iron is at 400 degrees. Also, this light is in my way a little bit. And the HDMI cable as well. Oh, I resolved the solder bridge by picking up the solder. This is amazing. Me too. Wow. I thought I have only one try to reflow that. Never thought I could rework that. This is 0.5 millimeter deep down and 8 millimeter gap. And it's manageable. I never thought of that. This is amazing. I need to set up a camera to film that. What that looks like. Woo. This is crazy. I saw that when no one has saw that before. Yeah. Oh, that's. Huh? Oh, it's way darker. Somehow, I think this light moved away. Okay. I got quite far already. Hypodermic. So pick up some new paste. Oh, I'm getting better at this. New career path unlocked. Neurosurgeon. Wow. Wow. This is crazy. Never thought this would be possible. Especially as easy as that. Okay, let's fix the other ones that might have cold solder joints. There are plenty. Oh wow. Okay, so the second gap, I did a mistake. Look at this. This is the first gap that fits the syringe. The second gap. Oh wait. Interesting. It's a little bit smaller, but I can still fit. Look at, this is my finger. It's like this syringe. It's crazy, the sizes that we work here with. Yeah, so just for your orientation, a little bit of flux. I can already see a few cold solder joints there. Okay. Frosted joints. I don't know, I want some sharpness for you. Oh no, when I do it like this, I need to change focus for me as well. Okay, that might help. I bent my soldering needle here. Need to adjust to the new tool. Oh, it's not conducting the heat well anymore. I need to get some solder on the tip, because that fell off before. Okay. Here we go. Ah, still cold. Uh-oh. I caused the bridge. Oh no! Oh no! Look what I did to my connector by accident. Boo-boo happened. Thankfully it's the outer thingy here. I need to shave this off. Alright. Let me fix that. It looks bad. I hope there are no shorts. Look like that. Oops. This fell inside. Yeah, that's what's happened if what happens if you use 400 degrees on your soldering iron. Yeah. Shaving off any excess. My tweezers are dirty as F. Yeah, I can't get anything off there. Just need to make sure that there are no metal chunks in there. Yeah. Casper, you're still up. Oh yeah, tomorrow is free. Free day tomorrow. It's awesome, huh? Yeah, this you can't even see this with your naked eye if you look at that. So if I would zoom out, like you can't even see that. Anyways, I solved this solder bridge, and I think they're good. Casper's still up because I forbid. Sorry, Casper. You are allowed to go. There won't be any like tests or anything today that are worth staying. It's only rework time. I need more flux there. Nah, there won't be any shorts. I will check this later. It's not transferring the heat well right now. This is what worries me more. And the lighting is bad. Okay, I try this direction. Yeah, no, it looks like my wire's not heating up enough. Oh, the bridge might be gone. No, that's the wrong hole. Yeah. I get stuck to it. Okay, I give up after this one. I just resolve what I did wrong. And it doesn't heat up anymore. What's going on? Need to add some solder to the tip for a better heat transfer here. Yeah, the tip doesn't like stuff anymore. Okay. I'm stuck. It's not hot enough. I don't know why. It was hot enough before. No, it's not. Might want to change the wire. Oh. Interesting. Maybe the soldering iron thought I'm not soldering and turned off for some reason, because now it's working again. And I take this position. I can't see well. Okay, there's still this solder bridge. Ah. By the way, the pins are still in place, so they're all alright. So they're deeper in here. Look at that. There is the pin there. So they're on this side, and this side is okay. This side of the connector doesn't matter that much. Oh, that's a good view. What is with these pins? They're really stubborn. It's like get really stuck there. Maybe that's one of the power pins or something. Oh, that could be the VCC pins. They have some thick wires going on. Oh, I had it. I had it for a second. Damn. Where do I remove this solder? Now I have two bridges. This is dreadful to watch. I just distribute this solder. Okay, I'm in the flow again. Just need to be careful not to mess up things. It's certainly a cold one. Yeah, I need some little bit of recording though. Okay, solder bridges. These are the worst pins there. one doesn't even want to melt. Oh, really? What are the others doing? Maybe not liking. Oh, the soldering iron turned off. Stupid thing. Okay. I didn't like the angle or what? Just because the angle changed. Oh, look at this! It fell apart. I completely destroyed this wire. Okay. Ah, I need to do a new soldering tip. Now this one is 400 degrees. Let me get this off. Crazy. It corroded away completely. Wow. 400 degrees seem to be like very bad. Where did I put the wire? No, down there. I need to make it flat at the end again. That worked well. Like a chisel. Yeah. Green energy, yeah. Hello, who's there? Okay. New tip, new luck. Safety pin. Oh, Christian. I burnt myself a little bit in the process. Okay, let's see how well the new tip works. It's too cold. Too long. Then I'm using low temp soda paste. Still too, okay, that's too long. To make it shorter though. Okay, now without flat tip, let's see how well that works. Workable. So the bridge is gone. The burns on my finger are still there. Yeah, that looks like I need to do some extra work here. I do every other pad now, so I won't cause solder bridges while I have a lot of solder on my tip. Wait, we refilled those already. Yeah, I can create a huge solder bridge probably. Yeah, and that's only 670 pads, my friends. Okay. There is no more flux. Need more flux there. Now I can't see shit anymore. I already adjusted to my new tool. Yeah, I know. Almost resolved it. And it's gone. Okay, peeps. This marks the end of the stream. We can check off all the things of our list. I think I will stream on next Monday again. I take the Friday off. Maybe. So turn on notifications if I feel like it. But I want to watch a movie for once in the evening or something. right. Two connectors are completely soldered. No, two more. One, two. Messed up a little bit, but all right. I'm happy. I'm happy with my new tool and with the result. That's so cool. I will show you how it looks like this molten connector. Here. Yeah, you couldn't tell if there wasn't like a shadow or something. Yeah, once the cards are in, it will be alright. Ah. That's it for today, everyone. Oh, I streamed longer even than I thought I would. I see you on Monday, okay? Bye bye everyone, good night. That shows the real scale, yeah. If you want to see the size of the wire which I used to solder, here it is. So this is the thing. This is the usual tip. This is how I soldered it. Beep, 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 beep. Bye bye everyone.